So hi viewers. So today I'm taking one small question here, previous year's questions, right? So Aldol condensation reactions applications. So they are asking the question Aldol condensation related, but nowadays they're not asking direct question for on that Aldol condensation reactions. So they're asking like that different reagent they're given in the orders. We have to find the major product or final product, right? Here I took one equations or reactions here. So here two reagents are there. One is diisobutyl aluminum hydride is a reducing agent, and one more is potassium hydroxide base followed by heatings, right? So anyone can expect for this. So what are the first reactions? First, the compound is treated with reducing agent diisobutyl aluminum hydride. It is a selective reducing agents. So particularly which groups are reduced to which compounds or which functional group means particularly ester functional groups. So the ester functional group is converted into aldehyde, and one more is cyanide. Cyanide group also converted into aldehyde functional groups. So it is a selective reducing agents. So diisobutyl aluminum hydride. So one is ester converted into aldehyde, and one more is cyanide group functional group is converted into aldehyde functional groups. So first we have to apply first reagents. So if you go for diisobutyl aluminum hydride, so what is the which groups are converted into aldehyde means here is one ester functional group, here also one ester functional groups, right? So both the ester functional group carbons converted into aldehydes, right? Now we can write that product CH3 CH, here is CHO aldehyde, and here is CH CHO, right? And followed by the CH2 and CH2 and C double bond O CH3. So here keto functional group is not disturbed. So that's why diisobutyl aluminum hydride is a selective reducing agents. So particularly ester functional group and one more is cyanide functional group. Both the groups are converted into aldehyde functional groups, right? So without disturbing the keto functional groups. It's the first reagents diisobutyl aluminum hydride, right? Second, we can take it KOH and delta. So now we have to apply it for Aldol condensations, right? So Aldol condensation reaction, because here delta also given that. So followed by heating loss of water molecule to form alpha beta ketones or alpha beta unsaturated aldehyde or ketones are produced. Now we can check it. So where it is produces aldehyde condensations. Here is aldehyde functional group. Here also aldehyde functional group. Here is keto functional groups. So we have three carbonyl groups. So two aldehyde functional groups. One is ketones, right? So first of all, so which one is reacted? Which one is more reactive? We have to go for the reactivity of aldehyde and keto functional groups. Which one is more reactive group functional groups? I already have idea about that. Which group is more reactives? Like due to that steric enzymes, and one more is electronic factors. So if you take the both the factors, aldehyde functional group is more reactive than highly reactive than keto functional groups. Keto functional groups because of bulky alkyl groups are present around the carbonyl carbons, and here is one side is hydrogen, one side is alkyl, or any other group is present. That's why aldehyde functional group is more reactive than keto functional groups, right? So here aldehyde and here also aldehydes. So two aldehyde groups are there, but which aldehyde group is reacted, right? This group or this groups, right? So it is both are acts as a substrate. Here is nucleophilic addition reaction is takes place or condensations. And one more group is there, keto groups. Here keto group is alpha carbons. So among these two alpha carbon, which carbon forms carbanions or which alpha hydrogens are involved in condensation reactions? It's a very important point, right? So we have idea about this aldehyde is more reactive than keto group. Suppose if you go for this aldehyde functional group, right, direct you can go for condensation, elimination of water molecules. For example, if you go for this alpha hydrogens, two hydrogens, here oxygen, elimination of water molecule. 1, 2, 3, 4. So we are getting the four membered ring. Four membered ring is unstable. You know that intramolecular aldol condensation reaction because it's intramoleculars. Because aldehyde group and keto functional groups are present the same molecules. So it is a application of intramolecular aldol condensations. Aldol condensation reactions. Right. Next, if you go for this side alpha hydrogens, right? So here alpha carbon alpha hydrogens forms carbanions. So Here is this two alpha hydrogens, and here oxygen is eliminated. One, two, three, four, five, and here is six member ring is forms. Here is possibilities that the elimination of water molecules by using alpha hydrogen and carbonyl oxygens hide from aldehyde. We are getting the six member ring is produced, right? So it's a six member ring is possible. Right? So not only this aldehyde functional group, you have to check with another aldehyde functional group also. Right? Suppose if you go for this aldehyde functional group is involved in aldol condensations. Like here is alpha hydrogen is two hydrogen, here oxygen is eliminated the water molecule to form which member 1, 2, 3, 4, 5. It's a five member ring is produced. Right? If you go for right side alpha hydrogens involved in the aldol condensation reactions. So here three hydrogens, here is oxygens. So elimination of water molecules to form aldol condensation. But we have to check the ring, cyclic ring. 1, 2, 3, 4, 5, 6, 7. 7 member ring. If you take open chain or aliphatic, so intramolecular aldol condensations. So which ring is more stable means the stability of ring is one is 6 membered ring is more stable, right? And greater than. Next one is 5 membered ring is more stable. Generally 6 membered or 5 membered rings are more stable. But among these 6 membered and 5 membered, which one is highest stability means 6 membered product is more stable. Right? So that's why we have to go for 6 membered. If you go for this aldehyde group means 1, 2, 3, 4, 5. If you go for this side alpha hydrogen atoms, here oxygen, carbon, oxygen is eliminated means 1, 2, 3, 4, 5, 6, 7. So 7 membered is unstable when compared with the this two rings. So for 6 membered and 5 membered, last one is 7 membered is less stable. Right? So that's why you have to check with 6 membered ring where 6 membered aldol condensation reaction is produced. 6 membered aldol condensations. So if you go for this aldehyde group, this side is 1, 2, 3, 4. If you go for this side alpha hydrogen, 1, 2, 3, 4, 5, 6. So exactly the 6 membered. If you go for this one is the 4 membered is unstable. If you go for this one means 1, 2, 3, 4, 5. If you go for outside alpha hydrogen means it gets 7 membered. 5 membered, 7 membered, 4 membered, and one more is 6 membered. So which one is highest priority or more stable product condensation means 6 membered is more stable. So directly we can go for the 6 membered means here oxygen, here is alpha hydrogen atom is eliminated. So elimination of water molecules in the presence of base aldol condensation reactions. So we are getting that elimination of water molecule to form 6 membered ring. Right? We have to calculate 6 membered is 1, 2, 3, 4, 5, 6. So directly elimination of water molecule you can go for the 6 membered ring. So whatever ring you can go for any direction. The 6 membered ring, right? Here CH3, CH2 double bond CH. If you go for here is a CH2 double bond CH means here double bond you can keep it. It is a aldehyde group CH group. Here is CH group. Here also CH group. CH group is adjacent to which group is there? It is ring means it forms a double bond O. Right? Here is double bond O means adjacent is CH, and here is what we are getting that here adjacent is CH. Right now, here double bond O is forms 6 membered ring. So 6 membered carbon, we are getting that which group is there here means double bond O is a 6 membered is formed. 6 membered is adjacent will be CH, CH3 and CHO. This is the major product. It's a 6 membered and double bond O, here single bond and double bond, here single bond, single bond. So this is a conjugations. So alpha beta unsaturated carbonyl compound is produced. So alpha means functional group, it is alpha, it is a beta. So alpha beta unsaturated compound, unsaturated compound. It is called aldol condensation product. That is a very important and very simple for this. We have to check it. How many possibilities are there? Is a 4 membered or 5 membered and 6 membered? Because here we have two aldehyde functional groups are there. Two aldehydes. Both the carbonyl oxygens are involved in condensation reactions. But where hydrogen atoms are eliminated means alpha hydrogens. If you go for inside or outers, inner alpha hydrogen and outer alpha hydrogen, both you can check it. So what type of rings are formed? So 5 membered is answer is there, 6 membered answer is there, and 7 membered or 4 membered. Different type of structures they are given. But which one is the major product means the 6 membered ring is major product. Right? Like that they have to go for different styles. They have to represent it like this here. Here double bond O, here is keto group. Right? So parallel we have to go for here is CH. Right? Here is CH3 and CH. So this is the major product. So take care children, it is a very simple and easy for this. But nowadays they are not asking for aldol condensation directly that. So they have to give it one structure, they'll give it, they'll apply for different reagents. Right? It's one simple example for that. I'll take one more question for previous JE question.